guys, so today we'll be looking at shadowing. It's a very important concept in Sui Move programming. So let's get right into it. First I'll be creating a package on Sui. Called shadowing. And shadowing is a very important concept in Sui Move programming. So what shadowing practically means is you declaring a variable and redeclaring that variable in the same scope or in a different scope, alright, and you are using the exact same name of the variable with which you've declared the variable earlier. So let me show you that in code. So let's create a variable called x and pass the value 1, right? And let's start from 0, very basic, and let's print this value here of x, and yeah. So value is what? 0, right? So let's build it and write a test so we can see what we have in our terminal. So this is a test function. What to test the function mean? Just import the function after test. Yeah, so let's run this. Now let's test. So got 0. So I said shadowing is doing this. Come here, say let x is equal to that same x. This is shadowing. We are redeclaring it with the exact same variable name. So let's build again. It's going to throw a warning that we did not use the first x. We can silence that warning, alright, by saying allow unused variable. So let's build again. Fine. Then let's test. Just my habit, I don't like seeing anything like flags, right? So see that the value changed. So what is happening here? In the memory stack, x is being rebinded to the value x. So we are just particularly doing, we are just creating new memory spaces or memory storage in our memory, and we are just rebinding it to the variable x. It's different from mutation actually. So I'm going to explain that to you using a diagram. So let's draw a diagram so you get the good picture of everything. So this is a memory stack, is what I'm doing. I'm doing the memory stack, right? So and this memory stack, this is storage that has the value 0, which was declared by saying it is equivalent to x. Declare x as 0. So this is binded to x. Now shadowing is, you are now redeclaring that again. That implies that on the memory we're going to do the same thing again. So creating another storage in the memory and call it 1. Right? Call it 1 and rebind it the x. So can I as well do the third time shadowing? So the third time shadowing, this is the memory stack, right? So memory stack, how it operates is first in, last out, last in, first out. So based on the concept of the memory stack, this is explaining clearly how the shadowing works using the memory stack. So the guy at the top of the stack is preference over every other data in storage. So 1 is picked up, is shadowing 0. So let's now redefine again by creating 2. Let's call this 2, right? And we are binding it to same x. So what we're going to see here is now what we're going to get is 2, of course. Let's do that here. X is equal to 2, right? So if we build and run our tests, we get 2 right away. But now what happens when, in the memory stack is also aware of scope. I mean different scope, global or local scope. So what happens if there is a scope inside this memory stack? That implies a stack in a stack. So let's create a smaller stack. This is a local stack, right? So this is global, and this is local stack. What can actually cause a local stack? Writing an iteration, writing a condition statement, or creating a block, right? So let's in this stack want to make the value be equal to 3, right? And we want to see perform shadowing. Does it tell us here? So what happens here is it gets to this stack. Remember, this is a local stack, so at this point the most preference here is 3. The value of x changes to 3, but on exiting this stack it goes back to 2. It goes back to 2 because this stack is not being, it is not, the value that is going to be left out of it was not properly managed to be passed into the global stack, because the global stack has the final value on top of each stack as 2, but inside this stack you have the value of x to be 3, so it is expected that if this has to persist, it has to save or manage this value in order for it not to be erased on escaping or on leaving this particular stack. So this is a code demo. Now let's create a stack by creating block. Let's say let's x is equal to 3, right? Now let's look at what it is inside this block and print out x. So I also put an indicator so you know when we're inside local stack. So let's go. So let me do this too. Okay, let's build. Right, we built, and let's test our view. Now value before the local stack is 2. Inside the before the local stack, inside the local stack is 3. Value after the local stack is 2, based on what I explained here. So that's how it works. So what makes this different from mutation? Alright, so before I go into code, let me explain what makes it different from mutation. As you can see, for every shadowing we are redeclaring this, and the declaration has to do with memory consumption. So you're saving things in the memory, you're resaving it. The only difference here is it is the same variable. So the simplicity here is it is remapped to x. So you're saving, but you're remapping to x. So now how it stands to be different from mutation is this, right? In mutation, so mirror stack in mutation, So in mutation, what happens in memory stack is you don't redeclare anything, you just declare once and you mutate. So simple as that. So let's call these guys here, and let's call this guy y. So now in mutation, we are not saying okay fine, let's create another memory, right? Let's use another storage in memory. We are not using a new storage in memory, we are using the same storage. Picture it in this format: all this memory storage are an apartment, and I'm a peaceful guy, so I don't want them to pack out. Instead, okay fine, let me get a new space, call it a new apartment, and I just own it, call it. But now I'm saying no peace, man, right? This is going to happen this way, the rough way. This is my apartment, I want you out. So I'm saying I don't want 1 0 anymore, I'm done with you 0, get out. That's mutation. 1, I'm done with you, go off. That's mutation. So you use the same memory location in mutation, but in shadowing you don't use the same memory location. And in shadowing you redeclare. In memory, in mutation you don't redeclare, you primarily just use what you've already done before. So I'm going to create another module for that. So let's create a function, public function, and let's call this guy y, pass it 0. Now for mutation to be possible, you have to tell compiler that this variable can be mutated, and you say y is equal to 1. This is mutation. But if I'm to do shadowing, I don't have to do this, I just have to say y again, another redeclaration, you understand? So that's as simple as that. So that's the disparity, right? So we can actually test this. Let's write a test. So mutation test. So just let the compiler know that this is a test, and put the function test main. What's the name of function? Main, yeah, test main. Sorry. Then yeah, of course you have to import mutation main. Yeah. So let's build. Very important. Building. So I use variable y. So now let's print. So referencing y, and now before we change y, let's see what y is, right? So let me print again reference of y to, yeah. So build again, compiled correctly, and let's test it. Then let me add a label to this, very important. For mutation, right? For mutation, yeah. For mutation, then after mutation. Okay, all good. mutation 0 after mutation 1. So yeah, that's it. That's the difference between. Now, when you use sharding, so you use sharding in a situation whereby you're trying to, you want to typecast, a very practical way you want to typecast, and you want to change a variable from a type to a completely different type. You don't want the stress of typecasting. Sharding is handy. So let's create a model to do that. So usage, yeah, like that name, usage. So I have a function, public function, coming. Then we want to say let's an account first. An account should have a balance, so we're weak in programming. Let's call that. Okay, so account, let's start with an address. So right, and yeah, let's print what the account will be. Of course, it's going to give us an address, right? Now let's build. Now as we're building, let's create a test for that to see usage test, test model, and so can come here and say public name function name. No, sorry, test first, test, okay, function, test. So what are the tests then? The main function usage model. So I have to import usage model, import me, right? Yeah. So let's build the building. That is that. Okay, let's test it. It's supposed to give us an address. Now I want to switch. Okay, fine. In a situation where I want this account variable to trust the account balance, right? So you can just come and say 100C, right? Yeah, you can do that, right? So yeah, you can build again. Now we have to cushion that warning. So that's because this has to be consumed already. It has been shadowed, so it's not legible actually to compile. So what we're going to do now is just allow unused variable, right? So let's build. It should not be a challenge. Then yeah, test again. So I have this. Now let's say there is a provision for account or not an account. Now let's say account, this is not an account, right? False. We're going to have let's build first. Of course it's going to give us false. So you can actually typecast this, alright, in a rational manner. So false. So you see, you guys, it's very, very important, and the concept of shadowing is very important. You can see what shadowing is. You've been able to learn what shadowing is. The difference between shadowing and mutation, mute, and the usage. Alright guys, stay tuned. We'll release more videos about concepts like this that are important in Sui Move programming. So when you're writing a smart contract, it's very seamless and very efficient. Alright, thank you guys, and don't forget to subscribe.